and welcome to Age of Reason. So today is Monday, March 6, 2017, and today we're going to do something a little bit different. I'm going to start what I call the interview series. So this is where I interview an expert in the field, and mostly it will be scientific fields. So today I have the great honor and pleasure to be talking with Dr. John Cook. Dr. Cook is the creator of skepticalscience.com. To date, according to Google Scholar, he has 1,370 citations. He has a PhD in cognitive psychology, and he's currently the research assistant professor at the Center for Climate Change Communication at George Mason University. Joining us now from Washington is Dr. Cook. Good morning.
Good morning, Jesse.
How's the weather in Washington?
It's weird. I've been here for a month. I just moved here from Australia, and I came expecting the worst in terms of winters. We don't really have winter in Brisbane, in Queensland. And it's been freezing one day, warm the next, freezing the next day. I haven't quite figured out what season I'm in yet.
Do you think this trend is going to continue into the future with the impacts of climate change?
Overall, on average, it will be getting warmer. We'll be seeing less snow. And there is some evidence that weather becomes more variable as we experience global warming, although that's an ongoing debate. So it's difficult to say. Weather is always chaotic. It's a tough thing to predict.
Sure. So we're actually going to jump right straight into the first question, which is related to that. And if you can just tell us, what is the difference between weather and climate?
Right. I mean, and it really fits in nicely because weather is what we experience and it changes from day to day. And climate is just weather averaged out over time and usually over bigger regions as well, over a region or a country or over the globe. And so weather is chaotic. It is more difficult to predict, although scientists are getting better and better at predicting it as the years pass. But climate is a lot more predictable because you are taking the average. It's like rolling a dice. You can't predict what the dice will get once. But if you roll the dice 1,000 times, you can predict that you're going to get 1 a certain number of times and 6 a certain number of times with a fairly good degree of accuracy.
Sure. And just a kind of side question. Do the meteorologists and the climate scientists use the same climate models, or do they use different techniques?
My understanding is they're actually converging. There was actually an interesting podcast by Graham Redfern. He's got the podcast Positive Feedback, where just this last episode he interviewed a climate modeler from the University of New South Wales, Stephen Sherwood. And Stephen was talking about how climate models are becoming so sophisticated and computers are developing so much power now that climate models are becoming closer and closer to being weather models that they average out over time. In the past, it was more, it wasn't quite that high resolution. They weren't getting quite so detailed that they were working out the weather over time. Now they're getting more that way, and so they're just becoming more sophisticated and better at predicting short-term climate trends.
Sure. That sounds quite familiar, actually. With better technology, we'd get access to better information. It's the same with space telescopes, for example, right? So, okay. So when we speak about climate change, we really have to speak about abrupt climate change because we are causing things to change so quickly over short periods of time compared to climate change, which may have changed before, but took maybe thousands of years to change. How do we know that humans are actually changing the climate? And do you think there will be any benefits to this fast change of climate?
The reason why we know that humans are causing climate change is because we see our fingerprints all over the climate system. We're measuring what's happening to our climate in many different ways, using thermometers, using satellites, and we're seeing all these different patterns. And the patterns that we see are exactly what you would expect to see if greenhouse gases were causing the warming. And they also rule out a lot of the natural causes that have driven climate change in the past. So let me give some examples. Satellites are measuring how much heat escapes out into space. And if greenhouse gases are trapping heat, then we should expect to see less and less heat at those exact wavelengths where greenhouse gases absorb heat. And that's exactly what we've seen over the last 4 decades. Less and less heat escaping the space at the wavelengths where greenhouse gases absorb energy. So that's it's essentially a smoking gun fingerprint, but that's just one. There's many different fingerprints. We see it in the patterns in surface temperature. Winters are warming faster than summers. Nights are warming faster than days. We see the structure of the atmosphere changing. The stratosphere, the upper atmosphere is cooling at the same time that the lower atmosphere is warming. This is what you would expect to see with greenhouse gas warming, and the opposite of what you would expect to see if, for example, the sun was causing warming.
Right, right.
There are a few benefits, like there are cold areas of the world that as it gets warmer, it enables things like agriculture at high latitudes, for example. And there are fewer cold-related deaths. But the benefits from global warming are far, far outweighed by the negatives. There's so many negative impacts, and it's affecting every aspect of society. It's affecting health, it's affecting infrastructure, it's affecting agriculture. Sea level rise is threatening hundreds of millions of populations who live on the coast, and there's really no contest. The negatives greatly outweigh any small amount of positives that there might be.
Yeah, I think you mentioned the people living on the coast who might be in danger. If you look at countries like Bangladesh, for example, who really rely on, 1 meter sea rise for them is very catastrophic, for example, right?
It is, and the big irony with countries like Bangladesh is that they have contributed the least to climate change compared to the industrialized countries. And it was when I realized that I realized that climate change is really it's a social issue, it's a human issue, it's a justice issue. The people who are most impacted by climate change are the ones who've contributed to the least, and also they're the ones who are least able to adapt to it. And so I see climate change as not just an environmental issue, it's also crucially a human issue and a justice issue.
Would you even say that it's a moral issue?
Well, yeah, I guess that's another way of saying it's an ethical issue, it's a moral issue.
Sure.
For me, I really got a fire in my belly about climate change when the penny dropped, and I realized that it was a moral issue, and we as human beings have to make a moral decision on whether we're going to be concerned about this issue, whether we're going to act on it, and whether we're going to talk to to other people about this growing issue.
Some people, use arguments, or you would call them myths, I assume. Like, for example, they would say climate has changed before, or it's the sun. What is the percentage of public perception of the scientific consensus when we actually know that the scientific community is almost unanimous when it comes to the consensus? It's between 90 to over 97%, depending on the studies. Why do you think the public perception is not as high as it should be?
Yeah, so the public perception does vary across country, and most of the studies measuring public perception of climate are done in the US. The most recent and I guess reliable data, a survey done of the US population found that when you ask Americans how many climate scientists agree humans are causing global warming, the average answer is 67%. So the public think that it's quite low, the amount of scientific consensus. And in reality, it's around 97%, between 90 to 100, but a number of studies have found 97% consensus. So there's that big gap between public perception at 67 and the actual 97. Now, the reason why there's this big gap is a couple of reasons. One is that a lot of people just haven't heard of it. It's not something that you would see on TV, like mentioned all the time. It's something that you have to kind of be engaged with the climate issue to really be aware of. But I think more importantly, there's been, for decades now, there's been a concerted effort to misinform the public, to cast doubt on the consensus. Explicitly, they've said in strategy documents amongst groups and people who are casting doubt on the consensus. They're saying if you want to delay policy to mitigate climate change, if you want to stop climate action, cast doubt on the consensus. If the people think that the scientists don't agree, they're not going to support climate action. This was back in the 1990s when this strategy was written. So that's nearly 2 decades ago. Decades of misinformation and casting doubt on the consensus has had an impact. The public still think it's only 67%.
I think you mentioned in one of the lectures, and I should mention actually what I'm talking about here, is that of course you were the main host of Denial 101X, which is a great course, by the way. It's available on Coursera and edX.
edX, not Coursera.
Oh, edX.
2 completely different platforms.
Yeah, that's true. It's available on edX, and some people might say, well, it's just an online course. It's not very serious. But I spent 3 years in university, and I feel like I wasted most of my time there because it was not very focused into what I was looking for. So these short courses are great, I think, and they're free. So unless you want a certificate, of course, but otherwise they're free and great resource. And thank you again so much for doing it.
And just to clarify too, like the course, it's an online course. It's free. It's very accessible to people, but it's also a very rigorously produced course. It was reviewed quite extensively while we were making the course. Before we even had made the course and we announced that we were doing it, the university started receiving complaints. Wow. And so the university was reviewing and double checking, triple checking, quadruple checking our content before it even came out. So it's possibly the most rigorously reviewed online course that's been published online, and we put together a lot of strategies to make it robust, to make the content. So we firstly we had our lectures reviewed by external experts. When I put together a lecture citing studies by scientists, I often got those actual scientists to review the lecture to make sure it was all accurate. We reviewed it internally at the university, and we also referenced peer-reviewed literature as much as possible and included all those references in the course.
I think in one of the lectures you said that the current strategy to cast doubt on the climate consensus was actually developed by the tobacco industry. Is that true, or?
Well, I don't know whether they were the originators, but they certainly perfected it. They developed these strategies to cast doubt on science to a degree perhaps not seen before, and implemented it, poured millions of dollars into it to be really effective in confusing the public, and I guess doing exactly the same thing as climate change in that lowering public perception of scientific consensus, making the public think that the scientists didn't agree that smoking causes cancer. And the longer they could delay that, keep that public doubt going, the longer they delayed policies regulating the tobacco industry. It was all about keeping their profits coming in as long as possible. And we're seeing the same thing with climate now. They keep the public confused, they can keep burning fossil fuels, keep selling their product, and keep the profits going just a little bit longer and make a little bit more money, or a lot more money.
Right. So in the US right now, there is a very aggressive Republican agenda to ignore man-made climate change. We have a president who thinks it's a hoax, and not just him, but people in his cabinet as well. They want to defund the EPA and other legal environmental safeguards. My question is, can a country effectively decrease its CO2 output despite the top brass promoting the fossil fuel industry?
In theory, it might be possible. I think there's a lot going on in the way of climate action independent of the federal government. You've got local governments and state governments acting on climate change. You've got industry acting on climate change. Everyone's waking up. Everyone sees the writing on the wall. They see the need to act, and they see that we're going to be going there anyway. The sooner we do it, the better. And in an industry where it's competitive, the people who get out in front will have an advantage. So there's an air of inevitability about it. But the real question is, how quickly can we make the transition from fossil fuels to clean energy? And it's the slower the transition, the greater the impacts from climate change. There's a really important way to think about climate change is it's not a dichotomy. It's not either we experience climate impacts or we don't. We are going to experience climate impacts. The real question is how much. It's a matter of degrees, literally. And so the quicker we make the transition, the less the impacts we'll experience in the future. The less we commit ourselves to future climate change going decades and centuries into the future, as well as right now.
I actually talk to many people, and even the people tell me, for example, that near Tokyo, maybe some decades ago, they used to have snow during winter, and now it's just gone. I was in France during the killer '98 summer, which killed, I think, 50,000 people because of the extreme heat that year. These things are real. I've lived through them.
I think that's a really important point to make. And when we talk about climate change, it's crucially important that we don't just talk about, and I kind of fell into that trap a few minutes ago, but we don't talk about decades or centuries in the future. We don't just talk about our children and our grandchildren. I've just moved here to Virginia, just outside of Washington, D.C. A few weeks ago, I visited Virginia Beach and Norfolk on the east coast of the US, and went around to a lot of the different places where they've experienced flooding events now. Like I could see puddles on the street where there never used to be puddles, and now it's just permanently inundated. And these areas are having to develop strategies to adapt to flooding now, because the flooding is happening on a regular basis where it never used to happen. It's not something that's going to happen far into the future. It's not something that's going to happen just to polar bears or faraway parts of the world. It's happening to places where we're living right now.
Right, and of course Florida, right? It's getting the bulk of the flooding. They're actually starting to raise up the city, which is absolutely useless in my opinion. I mean, in a few years, that's going to be flooded as well. So they spent money to raise the city, and just complete waste.
Well, what it does is it buys them a little bit of time. And at Norfolk, they're doing similar. They're raising streets, and at an incredible expense. It's so expensive to raise an actual street. And it might buy them a decade, a few decades, and it's a real problem, because at our current trajectory, we're committing ourselves to meters of sea level in the long term. And meters, it's almost impossible to imagine, but that's the scientific reality. So, like we can adapt. We have to. We're going to have to adapt. But more important than that, we have to mitigate. We have to change our trajectory and prevent the really dramatic climate change that otherwise we'd be committing ourselves to.
Why do you think some people who deny climate change seem to gravitate only towards fake news and misinformation, that they ignore the scientifically accurate sources of information? What can be done to move them away from alternative facts to actual facts? You talked about inoculating the people against climate denial. Can you talk a little bit about what it means and how it works and how effective it is?
Yeah, there's a lot in that question. There's a lot to unpack. So firstly, it's a universal human condition that we all gravitate towards information that confirms what we already believe, or information that reaffirms our identity or reaffirms our social groups. So that's just what we do. We hear something we like and we go, that's great, I believe that. We hear something we don't like, we fight against it, we argue, we try to find reasons not to believe it, we try to pick holes in it. So that's confirmation bias for things we like, and disconfirmation bias for unpleasant information. Now, in my own research, I've observed this exact thing. In one case, I presented misinformation about climate change to people, and what I found was liberals, people who are politically liberal, progressive, on the left-wing side of politics, when they received misinformation about climate change, it had no impact. They just didn't want to believe it. They engaged their disconfirmation bias. But when conservatives heard misinformation about climate change, casting doubt on the consensus, they were very receptive, and they lowered their belief even lower, and it already was quite low. And so that's an example of people processing information in different ways, and it's also an example of misinformation affecting one group more than another because it confirms their beliefs. So that tells us the way people process information. They not only believe it more readily, but they'll actively go out and find information sources that they like rather than dislike. So, and that's easier than ever to do that these days because we've got the internet, we've got Facebook, we've got cable channels that are so segmented that it's very easy to pick and choose information sources that tell you what you want to believe. That's contributing to this polarized environment more than ever, unfortunately. So that's the problem. So what's the solution to that? Now, in my experiment, for one group, I only showed them misinformation. For another group, I showed them a message before the information. And it was a message that warned them about the nature of misinformation. Now, the whole thinking behind this was based on a branch of psychological research called inoculation theory. Inoculation theory basically borrows from the idea of vaccination. We vaccinate people by injecting them with a weak form of a virus, and that gives them immunity to the actual virus. They build up resistance. So they go out into the world, they encounter this virus, they've got immunity, they don't get infected. Now, what psychological research has found is if you expose people to a weak form of misinformation, then when they encounter the actual misinformation, it doesn't influence them. They don't get infected by the alternative facts, right, so to speak. So I tried this in my experiment. I said that here is a technique that misinformers use to cast doubt on science. And I explained the technique that was used in the misinformation without actually mentioning the misinformation at all. I just talked about the technique. And then I showed them the misinformation. And after they had been inoculated, the misinformation had no effect. No effect on anyone across the political spectrum. Even the conservatives who were really receptive to the misinformation no longer worked on them. And what this tells me is that everyone, whether you're conservative or liberal, whether you're left-wing or right-wing, nobody likes to be misled. Once people are explained the techniques used to trick you, to mislead you, those tricks no longer work on them.
Yeah, that's interesting. So I forgot to mention perhaps that you do have a PhD in cognitive psychology. And so you actually get into people's minds and try to figure out how they think and why they think the way they think.
You're making me sound like a mad scientist. Brain alteration surgery or something.
But I think it's interesting to get into people's minds really and figure out how they think and why they hold certain positions.
Oh, absolutely. If you want to be an effective communicator, if you're, for example, engaged with the issue of climate change and you want to talk to people, you want to make a difference, it's crucially important that you are aware of the evidence into talking about evidence, the science of science communication. Because if you're not, then you can be, at best, you might be talking about science or climate change in a way that's not optimal. It's not the most effective way of doing it. Or worse, you could be making things worse. You could be causing your climate messages to backfire or causing people to shut down. There's lots of different reactions that people can have to information about climate change. And if you don't understand the psychology of it, you can either make matters worse or at least not be as effective as you might be.
Do you think the media is doing a good job reporting on climate change in general? My problem with the media is that, for example, if we watch some kind of news segment, they will invite one person who is well versed in climate science. Usually it's Bill Nye for some reason. And
you've obviously seen the John Oliver segment.
Of course. And they will also invite somebody who is not even a skeptic, but a denier. So it creates a situation where it's really 50-50. And so it does not represent the scientific consensus. What do you think about that?
Well, firstly, talking about that specific thing, when media portrays climate change as a debate between two equal sides, um, that actually misinforms the public. No matter what the content is, just having a 50-50 debate makes people think that there's a 50% consensus on climate change. I've tested that in one of my experiments. I presented climate change as a 50-50, and what I found was that lowered people's perception of consensus, which was already fairly low. It lowered their acceptance of climate change. That form of media coverage is misinformation itself. So a lot of the media do that. So I guess to answer your question, how do the media cover climate change? The general answer is badly, especially when they cover it in that way. When it comes to topics of scientific fact, it does the public a disservice to portray an issue as a 50-50 debate. You don't report on something to do with astronomy by getting someone who believes that the Earth is the center of the universe to balance out the astronomers. You don't do a news story about space travel and go, well, let's get someone who thinks that the moon landing was a hoax just to balance it out. It's not appropriate, and it's also not appropriate for climate change. Now, that said, a lot of the media has gotten a lot better on it. For example, the prestige press in the US has been studies looking at how they've changed over time, and they have gotten better. The balance that they, like the voice that they give to, I guess, people who deny the scientific consensus has dropped to the point where it's fairly reflective of the actual scientific consensus, the 97%. But there are other elements of the media that are not so good. So TV, not so good, and the tabloid press still not so good. And those outlets reach a lot more people, so we still have a bit of a problem.
And of course, the internet too. I mean, if you have an article today, it's so easy to just share an article which is pure misinformation.
Yeah, I mean, there was an analysis done late last year by a website, Desmogblog, and by Graham Redfern, who's a journalist based in Brisbane, where I just came from. And he looked at the most shared articles about climate change in 2016, and the most shared article on social media was an article casting doubt on the scientific consensus, citing a petition, an online petition, to say lots of scientists have signed this petition, therefore there mustn't be a consensus. And the thing about that petition was 99.9% of the people who had signed that petition weren't climate scientists. So the petition was using the technique of fake experts to confuse the public. And it's unfortunately quite an effective message, and according to last year, quite a widely shared message.
What are your main worries or concerns by mid-century? What if the set green goals currently are not achieved by then? And perhaps even worse, what if your efforts or my efforts to talk about this issue actually don't have any effect in the end? Well, what's your thinking on that?
It's difficult to say because I'm not that, I guess, expert on the relative impacts. Like there's so many different ways that climate change impacts, and I'm not sure which are the most damaging. But I think that I think food is probably one of the biggest concerns. And agriculture is affected in a number of different ways. Inundation, where you have food near the coast from sea level rise. Extreme weather increase, so like drought and both flooding are both intensifying because the water cycle is actually going from this to a much steeper roller coaster ride, and so we're seeing more intense flooding and more intense drought, and that affects agriculture, that affects food, and so that affects people in a really direct way. I think that's probably one of the ways that humans are most impacted. While I'm talking about that, I'm also reflecting on the fact that coral reefs are being impacted, and that's not just an environmental issue either. It affects humans in different ways, and like tourism is the obvious thing. Like in Queensland, where I came from, we have the Great Barrier Reef. the tourism industry depends on the reef, and it's millions, billions of dollars every year. But more important than that, coral reefs are these ecosystem hubs. It's fishing industries depend on them for existence. And so, like the Great Barrier Reef, 50% of it has died over the last few decades. Reefs are under great threat from warming oceans and acidification, CO2 being absorbed and acidifying the ocean waters. And so that's threatening fish populations, which is threatening all the communities that depend on fish for food. So again, it comes down to food and how that impacts people.
Sure. So just a final question. What are some simple things people can do to reduce their CO2 fingerprints?
While I was putting together the MOOC, the online course about climate change, I asked all the experts, either climate experts or people working in solutions, what do you say when people ask you, what can I do to make a difference? And it was really interesting. There was a whole range of different answers, but you could really group the answers into two things. The first thing is I call the walk the walk answers, and that's just reducing your own carbon footprint in different ways, whether it's just living more environmentally friendly, solar panels, or changing your light bulbs, or carpooling, or using public transport rather than driving to work. Just those simple individual actions that can reduce your footprint. And those things are important. But the other group of answers are, I think, far more important. And I call those the talk the talk options. It turns out, well, what we need to do to really avoid the worst impacts of climate change is transition our society from fossil fuels to clean energy. And the way that needs to happen is we need to change the way society, the way the public think about climate change. Well, firstly, just make them aware of it and get them supporting climate action. And when the public care, then the politicians will care. And so what we need to do to make that happen is just talk about climate change. Talk to our friends, talk to our families, talk to our elected officials, let them know we care about it. If they realise enough voters care about it, you'll magically find that politicians will start caring about it. And at the Centre for Climate Change Communication, where I work, we recently did a survey that found that even people who are concerned about climate change don't talk about it that much. There's this climate silence, which is a real problem. We need to break that silence. We need to get out there and start talking about this issue. And I think that if enough people talk about it, we will start to build momentum towards the kind of climate action that we need.
Sure, and I think the conversations about climate change are increasing in general. Actually, after the last time I talked to you, literally a few minutes after that, there was a live stream from Bernie Sanders and Bill Nye talking about climate change. So the conversation is really expanding, and we need much more of that in the future.
Yeah, I hope you're right. I hope that that the conversation is building and momentum is building, interest is growing, concern is growing, and that action will follow.
Okay, thank you very much. Do you have any final comments?
Okay, I will have one last comment. I've got a gratuitous plug. And now I talked about the importance of the science of science communication and talking about the evidence into how to talk about evidence, the social science research. Now, that's something that obviously I think is quite important. And so over the next few weeks, we're starting a podcast that we're calling Evidence Squared, because it's talking about the evidence into talking about evidence. And so, yeah, you can go to evidencesquared.com now and sign up to be notified when our podcast launches. And each week we'll just talk about scientific research into science communication.
I was actually going to plug it for you, but thank you for doing that.
You would probably have done a better job than I.
I did my research. You can also find it on Facebook if you just type @Evidence Squared. Of course, don't forget skepticalscience.com, which is a great website with a lot of great information and debunking climate change myths really one by one. I really recommend that. And of course, the online course, Denial 101X.
Right. Thanks a lot, JC. That was really good.
Thank you very much. Thank you for your time. And that was Dr. John Cook with us. So thank you for watching, and join us next time in our interview series.